Have you ever seen an ugly insect through a magnifying glass? You know the whole Sherlock Holmes said. You know my methods, Watson. This weird thing forms around the glass. What if you're told that happens in space too? Well, my point is, take a glance at these. Does something seem similar in these two? Gravity. No? Still get it? You know how our old man Einstein said that gravity is not a force, but mass influence on space and time. Space-time. Which was a lot different than Newton's universal law of gravitation. So, talking about the pictures, this snap was taken by Hubble Space Telescope, which apparently looks like a smiley face. And this is just a black hole who likes to eat a lot. This phenomenon is called gravitational lensing, which helps us to study celestial bodies which are unimaginably far from us. Talking about a black hole is just a great example. So what happens is there's a massive object, the black hole, and a galaxy behind it. In reference to you, as you're probably on Earth and not anywhere else in the universe. So it's definitely that we might not see the image of the galaxy. As per our knowledge of school physics, the black hole takes up all the light coming. If you're thinking like that, then my friend, that is not what happens up there in space. You're wrong. Black holes have huge amount of gravity, and according to general relativity, it makes enormous curve in space-time. So the light coming from the star with the speed of almost 300,000 kilometers per second is bended around the black hole. Okay, another question for you. What do you think we noticed then? Think about it a bit. Okay, two things happen. A. The light bended around the black hole or whatever the gigantic body you have in mind, and its images are visible at multiple points in space. And B, if a black hole passes by, at the point when it's exactly after a galaxy, it causes to form a ring-like presence around it, which seems totally weird at first, which is by definition called Einstein's ring. When the image is seen, it is very large, just like the magnifying glass. Remember? But can a star do all the bending and stuff? Yep. When this Brit dude Eddington did an experiment to see if Einstein was correct about curvature of space and all. Guess what? He used our sun. Yes, I repeat, our sun as gravitational lens during a full solar eclipse and observed the source as the star, and the image was formed else than the source's real position, which made general relativity a superhero of theoretical physics. Hold up, this was barely it. There was so much more. One thing that scientists could not grab on was that between the clusters of galaxies, there was something that just exists. The empty space between the cluster was not empty. Discovery of dark matter. Pretty much unobservable, pretty much indistinct, but it's pretty cool.